We are still on mensuration of plane shapes. Next is trapezium. A trapezium is a quadrilateral, that is a four-sided shape with two of its opposite sides being parallel. As you can see in the figure on the screen, the side labeled A is parallel to the side labeled B. That is these opposite sides. So let's change the color of the pen. This side is parallel to this other side. And that's the basic thing about a trapezium. Find the area of a trapezium. And the expression is simply given as area of trapezium said to be half the sum of the parallel sides, sum of the parallel sides. Multiplied by the height. Now the height of the parallelogram is simply the vertical distance or perpendicular distance between the parallel sides. In the diagram here, it is indicated as h. So which means I can reduce this to half some of the parallel sides. The parallel sides here are A and B. So that's A plus B, those two lengths, and then times h. That's the primary formula for obtaining the area of a trapezium. And that's today. Now, as we know, life isn't all that easy. Situations will arise where the height is not provided. And when you are not provided with the height, you will be given the length of any of the slant sides, either this length as L or probably this other length. And under such conditions, when you are given this length, you will also be provided with this angle here. We call that theta. Or you may be provided with this other angle, theta. Whichever of them comes in, this will help you to obtain your height. You can simply say that the height is obtained as what? L sine theta. By looking at a right angle triangle there and applying the trigonometrical ratio using sine theta as opposite, which is the height, and then hypotenuse the length, and then you will obtain the height as what? H equals to L sine theta. And then the area of the parallelogram in that situation will then be half, again, sum of parallel sides A plus B, and then in place of the height, that's your H, you will just have L sine theta. And that's all. So this is your height. So that's a special case there where the height is not provided. The two parallel sides A and B, let's put there B provided. But in place of the height, you have been given the length of one of the slant sides and then the angle which it makes with any of the parallel sides. All you do there is to do what? Find your height by taking L sine theta. And that's it. So both formulas are there on the board. Area is A plus B divided by 2. That's half the sum of the parallel sides times the height. The right side formula represents the height as what? As L sine theta. Now with these two expressions, we can handle any problem that has to do with trapezium. So let's set out. First problem here, very straightforward. Find the area of the figure above. The two parallel sides have been given as 10 and 14, and the height has been given as what? 7. That's the height. So what's the area? As we have said, the area will simply be half the sum of the parallel sides, that's your A plus B, times the height. And that will give us what? Half sum of parallel sides 10 plus 14, and then the height 7. And that gives us 24 divided by 2 times 7, which reduces to 12 times 7, and I'm very sure this will be 84 centimeter square. That's our first problem solved. That's it there. A plus B divided by 2 times height 10 plus 14 divided by 2 times 7, and that gives us 24 over 2 times 7, which is equal to 12 times 7, equal to 84 centimeters square. Next, this is the same thing as the first. You can see the right angle symbol there, helping us to see that the 6 provided here is the height, because this is right angle. So this side is making an angle of 90 degrees straight away. So that's the perpendicular distance between the two parallel sides. That is, this side and this other sides are parallel. So automatically our 15 will be our A, and 21 can serve as our B, while 6 is the height, H, because it is the perpendicular distance between the two parallel sides. So again, the area, as we are asked to find there, will be what? Half the sum of what? Parallel sides, 15 plus 21, then times the height, which is 6 in this case. 15 plus 21 gives us 36 divided by 2 times 6, and that's what? 18 times 6, which will give us, I think, 108, if I'm not mistaken. 6 times 4 is 48, and then 6 times 1 is 6 plus 4. That's 108. Let's not forget the unit, centimeter square. Take note that I simply went straight that 6 is my what? The height, because it is indicated there that that line is perpendicular to the parallel sides. Well, that's it there on the neater form, what we've just solved. So that's it, 108 centimeters square. Now the word problem here. The parallel sides of a trapezium as 11 centimeters and 13 centimeters. If the area of the trapezium is 84 centimeters square, we are asked to calculate the distance between the parallel sides. Obviously, by asking us to get the distance between the parallel sides, we know that we are looking for what? The height. The distance between the parallel sides simply represents what? The height. So we are asked to find the height of the trapezium. We have been provided with what? The parallel sides, that we have been given one parallel side as 11. We have been provided with the second parallel side as 13. And we are also given the area of the trapezium. So we don't need to find the area anymore, as 84. Of course, fixing this into the formula, our formula is area of the trapezium should be half the sum of the parallel sides, A plus B, times the height. Now we are told that the area is what? 84. And therefore this is half parallel sides 11 plus 13, then times our height. Of course, 11 plus 13 is 24. That will be 24 divided by 2 times the height. Let's move up there. 24 divided by 2 is 12. So which means I have that 84, the left hand side, which is the area, is 12h. So what is the height? Dividing both sides by 12, we have h equals to 84 divided by 12, and this is 7. So that means that the height is equal to 7 centimeters. I'm sure you agree with me there that the distance between the parallel sides for that problem is what? 7 centimeters. Let's rub this off. Next slide should give us in a neater form. That's it there. The area is 84. The two parallel sides 11 and 13 divided by 2 when added, and then multiplied by the height. And that gives us 84 equals to 12h. 12 is obtained from 24 divided by 2. And then dividing both sides by 12, we have 84 divided by 12 to give us the height as 7. Above here, we are asked to do what? Calculate the area of the figure above. Of course, we can see the parallel sides A given to us as 9, B given to us as 11. But we are not given the vertical distance. The vertical distance in between should have been this. That's the height. But rather, we are given the slant length here as 8 centimeters. And we are also provided with angle theta as 30 degrees. As we said earlier on, in order to get the height, our height will be what? H will be simply that length times the sine of the angle theta, which means in this case it will be 8 sine 30. So to find the area, just a piece of cake again. Of course, half sum of parallel sides A plus B. In place of the height, we have L sine theta. So this is half 9 for my A plus 11 for B times 8 sine what? Sine of 30. Now we know sine 30 is half, that's 0.5. 9 plus 11 is 20, so we have 20 divided by 2. Remember, we are looking for area. Times 8 sine 30 is 0.5. 0.5 times 8 will give me 4. So I put my 4 there. 20 divided by 2 gives me 10. So the area of the trapezium becomes what? 40 centimeter square. Okay, let's put this in print form. That's it there. In place of the height, what do we have? We have L sine theta. That's in place of the height, or height. And that's it. 8 sine 30 to replace the height. A and B is 9 plus 11. And then we progress. 10 times 8 times 0.5. 10 is obtained from 9 plus 11, which is 20 divided by 2. That's how we get the 10. And then we have our final answer as 40 centimeter square. That's it for trapezium. Next, we'll look at circles, sectors. Look at the area of a sector, the length of an arc.